Alright, just about done with the book, Chapter 10, DHCP. Alright, this should be a relatively shorter chapter, not the big 50-60 minute videos that you have been watching. Alright, so remember, we're going to talk about DHCP version 4, DHCP version 6. And remember, what DHCP does is it hands out IP addresses. Alright, and you can do them in a couple different ways. There's manual allocation. Obviously, the administrator can assign pre-allocated addresses to the clients. Or you could do automatic allocation and then assign everybody a static IP address permanently from a pool. Or you can do dynamic allocation. Now, 9 times out of 10, you're going to do dynamic allocation, which means you're going to set up a pool and say, hey, I'd like you to hand out IP address 192.168.1.50 through 192.168.1.200 and hand those out. And then you have to set the time for your leases. You know, in Microsoft world, the default lease is 8 days. But depending on where you're at, like at the college, because there's so many people coming in the classroom and every 2 hours a new person comes in, they only have so many IP addresses to hold on to, so they change their lease to 24 hours. So the lease is, you know, how long you hold that address for. So just make sure you remember, 9 times out of 10 we typically use dynamic allocation. Alright, the DHCP process. It's discover, offer, request, acknowledge. And I've always remembered it as Dora the Explorer. If you spell Dora, D-O-R-A, it's discover, offer, request, acknowledge. Now, the 2 client portions are broadcasts, and that's going to come into play later on when we talk about this. So what happens is, over here on the right, you got your PC, and he needs an IP address. So he starts up, he looks and says, hey, I have not been assigned a static IP address, so I'm going to ask if there's a DHCP server out there. So he broadcasts it out. Because remember, he doesn't have an IP address. He's like, oh crap, I need an IP address. So all he can do is a broadcast, as he doesn't know where the DHCP server is. And then that way, if you have multiple DHCP servers, they'll all hear the message. So the broadcast goes out, discover, hey, I need an IP address. And a DHCP server hears it. So then this DHCP server hears it and sends him an offer. Hey, I can offer you address 100. Now, if there are 2 or more DHCP servers, they would all send an offer. Hey, I offer address 50. I offer address 100. I offer address 200. So all those offers come to the client. So typically your client accepts the very first offer. And then he says, okay, hey, I'm going to take address 100. So then he sends out a request, and it is also a broadcast. And he says, hey, I request address 100. And that way the other servers that offered address 50 and 200 would know he did not want their address. And at that point, those servers would stop. They would quit sending messages, and they would put their address back in the pool for the next guy. But the server we're using, he says, oh, hey, you're accepting my address. Well, that's awesome. So he pulls that address out of his pool and then sends the acknowledgement. Okay, hey, it's acknowledged you have address 100. So that's how the whole process works. Discover, offer, request, acknowledgement. Discover and request are both broadcasts. All right, now, why is it important to know that those are both broadcasts? Well, what do routers block by default? They block broadcasts. So by default, DHCP cannot go past a router, but we'll talk about a way around that in just a minute. All right, so here's the DHCP packet, if you want to look at how it was formatted. All right, when you configure a DHCP server on a router, remember your router can do this. Typically the only place you do this is a very small practice. Most places are using a Microsoft server for this operation, or for DHCP. With a Microsoft server, you can go in and create the pool, and you can assign it whatever you want. Hey, assign address 50 through address 100. You can't really do that with the router. With the router, you have to assign the entire network. So it's important, if you're going to address, do address 50 through 200, you got to exclude the other addresses of that network first. So in this case, what we're going to do is we're going to DHCP 192.168.10.0, but we don't want to send out address 1 through 9, and we don't want to send out address 254. So what we do is the very first thing is we create the excludes. So IP DHCP exclude addresses 10.1 through 10.9 and exclude address 10.254. Then we go into the router and say, hey, create the pool, we're going to call it LAN pool 1, and start assigning addresses in 192.168.10.0. Now as soon as you do that and hit enter on that command, he'll start answering DHCP requests. So that's why we have to do the exclusions first. Remember, your router is not, you're not able on the router to just say, hey, give out address 50 through 100. So you have to say, okay, I got to give out this whole network, so I want to cut out these portions first and then allow that. All right, and then you can also offer your options. Hey, everybody's default gateway is going to be this, and everybody's DNS server is going to be this, and everybody's domain name is going to be this. So you can put your options in there as well, and then end. Now, if for some reason, let's say your DHCP server goes out, you're like, oh crap, the whole server died. I lost the backplane on the router, blah, or the server. You can create this real quick as a fix, and then use it till you get the server back in operation. And then when you want to turn it off on the router, you just do no service DHCP, and then boom, it's dead. All right, so it looks like this. Remember, we do the exclusions first, then we create the pool, and we allow that. And remember, as soon as you enter this network command, he's going to start answering requests for addresses. So if this is an active network and you didn't do the exclusion first, he would start handing out address 1. So that's why we do the exclusions first. All right. So on the router, we can verify with show running and then pipe section DHCP, or show IP DHCP bindings, or show IP DHCP server statistics. And we can see what addresses have been handed out, how many hits of requests for addresses, things like that. And then here, the section DHCP would show you the section. Now DHCP in the running configuration is typically near the top, unlike ACLs, which are typically near the bottom of your configuration. So if you spam the space bar and you're like, crap, where's DHCP? Remember, when you do the show run, it would be near the top. All right, and then you go to the PC, hey, ipconfig /all to make sure you're getting an IP address, make sure you're getting the default gateway and that kind of thing. If you just want to check for the IP address, remember it's just ipconfig. Now, if you do ipconfig and you're looking for an IP address and 169.254 shows up, you're getting that from a PIPA, your DHCP is not working. You can do an ipconfig /renew and see if you'll pull the DHCP again. Otherwise, remember 169.254.anything.anything is a private IP address. Your PC starts up and he says, hey, I have to have an IP address. I have to have an address. Your PC cannot function without the IP address. So he says, hey, I look for a static IP address. Well, nobody typed one in. So then I'm going to do a discover, or a discover message. So he sends it out to the DHCP server. If no DHCP server responds within a certain amount of time, he then assigns himself his own address with the 169.254. Remember, that's called a PIPA, automatic private IP addressing. So a PIPA address is totally useless. You can't do anything with it, but the PC has to have an IP address. All right, so again, let's go back to the broadcast. And this is what happens. Typically we have a headquarters area, and headquarters has a DHCP server, and they have internet coming in, and they got the mail server, and they got all the servers there. And then 6 miles down the road, you buy a new office, and the new office only has 6 people in it. Maybe it's a physician practice, has 1 doctor and 5 supporting staff. So you're like, oh, well, I'll just do DHCP to those guys and do it that way. So the first thing you do is you set everything up and you put in the T1, and then you ping back and forth between the routers and everything works, and then you assign static IP addresses to PC2, and then he can ping all the way across and everything works great. And then you turn him to DHCP and boom, he can't function anymore because he's not going to receive an IP address. But you're stumped. You're like, well, if I put an IP address on there manually, I can ping the DHCP server. But if I change my client to DHCP, it doesn't work. Remember, the very first thing is a discover message, which is a broadcast. When that broadcast hits router 1, it's killed. So the DHCP server never receives those requests for those IP addresses. So what you have to do is you have to allow DHCP relay on the router 1. And what you do is you put one command on router 1, and then router 1 will take those incoming discover messages and convert them into something other than a broadcast. Now I don't remember specifically if it changes it to a multicast address to the server or if it's a unicast address to the server, but it changes it from a broadcast, and then it's allowed through there. So the command is IP helper address space the address of the DHCP server, and you have to apply this to the interface closest to the clients. So in this case, on this router, I would apply it here to this interface, and then so it would be IP helper address space here to this IP or this client, and then the address of the server, and then that changes these broadcasts from DHCP only into specific specific communication going to the server. So interface closest to the clients, IP helper address space, the address of the DHCP servers. Now, because DHCP broadcasts are formatted, the DHCP packets are formatted differently than everything else, it understands that the IP helper address says, hey, if it's a DHCP request, I can change it from a broadcast and I can accept it, but all other broadcasts will still be killed. So they call that the relay agent. Your router's acting as a DHCP relay. So again, where does the helper go? Closest to the client. So if I'm trying to put DHCP here on PC2, DHCP helper address goes to that interface there. Alright, so when I'm configuring the router as a DHCP client, which I have no idea why you would ever do this other than maybe if your ISP connects directly into your router and you need to receive an IP address from your ISP or something like that. So you go to the interface, so interface gigabit 01, and then IP address DHCP. Boom, done. And then no shut and bring it up. All right. So troubleshooting. You're looking for conflicts. You're going to verify connectivity. You pull DHCP off, or you just change from DHCP to a static IP address, and then you verify configuration and make sure that you're in the same subnet or VLAN. So remember, if I do show running show running configure, so show run pipe section interface gigabit 00, it'll just show me the information on gigabit 00, and I can also do show running include no DHCP service to see if that command has been issued on the router. So maybe somebody turned it off by mistake. All right, and then don't forget, there's always your debugging commands. Every protocol has a debug command. So if I do debug IP DHCP server events, anytime a DHCP event happened on the router, it would show it to me on the screen, and then I can kind of see what's going on. Checking for expired leases, this lease address has expired, blah, blah, that kind of stuff. And I could see it that way. And remember, to turn it off, it's undebug/all, and that way we're good. Or undebug all. All right, DHCP with version 6. In version 6, you've got a couple different options, and it's either stateful or stateless. Stateless, there's stateless address auto configuration, and basically it says, hey, your devices can configure their address themselves. So now I don't even need a DHCP server. I just need the router to tell you what your network portion is, and then the PC will assign himself the host portion of the address. Now you can do that a couple different ways. You can have manually assigned, host portions, or you can use, EUI64 to take the MAC address, split it in half, and add FFFE in the middle. Now, if you don't remember that from our IPv6 portion of the class, bring that up when you come in for lab day, and I'll go over that portion again. But basically what happens is, PC starts up and says, hey, I need an IP address. And then the router says, oh, hey, I don't have the whole thing, but here's the network portion. And then the PC says, oh, okay, now that I've got the network portion, I'll just generate my own host portion, and then I'll send it to you and make sure to verify you haven't received any other addresses that use this same host portion. And then the router would say, nope, you're good, and then everything is good. So I don't even need a DHCP server. I don't need to set up a pool and do all that other stuff. The router just needs to give me the network portion, and I'm good. Now, you can use SLAAC and a DHCP server. And that way, when the PC says, hey, I need an IP address, you've got some options. If it's SLAAC only, hey, here's the network portion. But if it's SLAAC and DHCP, it says, hey, here's the network portion, and I'm going to go to the DHCP server and see what you need for the host portion. Or he says, hey, I don't have this information, I'm going to send you on to the DHCP server, if we're only running DHCP, because I'm doing stateful. Remember, stateless, you don't really have a DHCP server, you're just going to send minimal information to the clients, they're going to configure themselves. If it's stateful, the client's there's going to be a DHCP server, and he's going to assign the IP addresses. All right, so how do you set it up in DHCP version 6? All right, first you got to enable IPv6, so IPv6 unicast routing. And then you create the pool, so DHCP pool IPv6 space stateless. Then you create the DNS, the extra options. So DNS server is going to be here, the domain name is going to be here. And then you go to the interface and say IP address, blah, and then IP DHCP server stateless, and then ND, remember neighbor discovery, other config flag. So 2 steps. 1, you're creating the address name. You're saying, hey, the DNS server is at this network, and this is the network that I'm going to assign or pass information out. And then you go to the interface, and whatever address is on the interface, that's the address information you're going to pass out to the clients. So if this client connects to gigabit 01, he's going to receive, hey, if he asks for an IP address, he's going to receive 2001 db8 cafe space 1 as his network. And because it's stateless, it's going to say, oh, now you can configure your host portion yourself. And then he would take his MAC address, if you're doing EUI64, pop that in there, split it in the middle, and add the FFFE as we talked about. If for some reason you wanted to set your router up as a client to receive an IP address, you just go to the interface, IPv6 enable, and then IPv6 address auto configure. Why you'd want to do that, I have no idea. All right, and then to verify your address, show IPv6 DHCP pool, check out your address. Remember, there's also your debugging commands, or check out the interface, show IPv6 interface. All right, if for some reason you wanted to make it a stateful, so you want to make him use the DHCP server, remember IP unicast routing, create the DHCP pool, the address prefix is going to be this, leases are going to be lifetime, DNS server, blah, domain names are your options. Then you go to the interface, give him an IP address, set him up as a DHCP server stateful, and then you do the discovery stuff for your messages for ARP. So in this case, you would be handing out specific IP addresses. In the other case, you're only giving out the network portion and then letting the client configure himself. All right, again, to verify, show IPv6 interface gigabit 1, and you kind of think, hey, he's got an address here. Where is he getting his default information from? So there's also show IPv6 DHCP pool, and then show IPv6 DHCP bindings to show you, the mappings. All right, it's a little bit different for the relay agent. Instead of doing relay agent, it's DHCP relay destination, but it's still the interface closest to the clients. So in this case, you're on R1, PC1 needs an IP, or I'm sorry, PC1 needs to get through to the DHCP server. So you go to interface gigabit 00. Remember, the interface closest to the client, IPv6, DHCP relay, and then destination, the IP address of the the DHCP server. And then end, and you're all set. And then if you want to verify that, show IPv6 DHCP interface, blah, blah, and it says he's a relay agent. And here are the destinations that he knows about. Here are the DHCP servers he knows about. So IPv6 DHCP relay, and then the destination of the server is this. All right, so again, same troubleshooting methods. Am I handing out the wrong IP addresses? Are my cables plugged in? The easiest thing to do to check DHCP connectivity, or to make sure if it's a DHCP issue, is assign a static IP address and see if that fixes everything. If that does fix everything, it's not it is a DHCP issue. So if a static IP address works, it's great. DHCP is not functioning. But if I put a static IP address on and I still can't get from one end of the network to the other, then it's probably a connectivity issue somewhere else. So there's also debug IPv6 DHCP detail, turns on all the stuff. So not all the time when IPv6 DHCP messages come up, you're going to see them on the router. So anytime a message comes in, anytime a message goes out, anything that involves DHCP, you're going to get that stuff on the screen. And then you can kind of use that. So basically, if you know it's a DHCP issue, and you know it's on that router, you can turn on the debugging and then have the client start up and try to pull an address and then see what happens, which part of it is getting killed. All right, and that pretty much wraps it up. Remember, DHCP on the router is notoriously easy. You're basically saying, hey, exclude these addresses. Here's the network I want to give out, and then other options if you want. It's the same thing with IP6. With IP6, though, you can even go one step further and not even create a pool. You can just use stateless and then something like EUI64 so that the clients can kind of configure themselves. All right, again, we're going to set up IPv6 and IPv4 in the lab when you guys come in for lab day. So again, if you have any questions, make sure you bring them to lab day. All right, see you in class.